Hi, my name is Aeshanashree Naikar and I propose SUGUMARAN and my matrix number is 33DCE20F209. Today I'll be presenting about practical task 2, which is severity of quenching.
The objective of this experiment is to study the hardness of different medium scale samples and their microstructures under the following conditions as received: annealed, normalized, water quench, ice quench, and oil quench. The apparatus used are 6 medium carbon steel samples, furnace at 910 degrees Celsius, tongs, Rockwell hardness testing equipment, beakers, oil and ice quenching medium, optical microscope, polishing machine with abrasives, bulk grinder, abrasive paper, flat glass plate with wooden framework, electric hot air blower, cotton, Naikar reagent which is an etchant, and Rockwell hardness testing machine. So step 1, we have to obtain 6 identical samples of medium carbon steel and keep one sample as the control. Step 2, we shall austenize all 5 samples for 30 minutes at 910 degrees Celsius. A pair of tongs is used to transfer the samples into the furnace. So after 30 minutes, we are required to remove the samples from the furnace and quench them in different mediums, which are oil, water, wine, and room temperature. We have to let the last sample to cool in the furnace to 400 degrees Celsius before placing at room temperature. So once all samples are cooled to room temperature, each sample is polished and microstructure is observed under a microscope as shown in the subsequent steps. So the question is, why is the sample austenized for 30 minutes? It is because of uniform austenization. Moving on to step 4, we have to obtain a flat surface on the specimens by belt grinding. Then, we must support a polished paper of 1/10 fineness on a flat glass plate. Polish the specimens rubbing in forward direction only. As a reminder, we should move to the next finer paper 2/0 and 3/0 once the scratches on the specimen are uniform. While changing from one paper to another, the specimen and your hand should be clean free from abrasive of the previous paper and the specimen turned to 90 degrees so that the scratches from the previous paper are at right angles to the scratches from the next paper. Next, we have to finish polishing the specimens on 4/0 abrasive paper. We must remember to wash our hands and also the specimens right after the polishing process. Step 7 is to do the fine polishing on the disc polishing unit. Take We have to take note that after fine polishing, we must clean off the polished surface of the specimen with water and dry it with an electric hot air blower. Step 8 is to etch the specimens with 2% nitrile reagent by swabbing for a few seconds. As soon as we finish etching, we must wash and dry the specimen. Basically, etching means engraving metal, glass, or stone by coating it with a protective layer, whereas nitrile reagent is the name given to an oxidizing etchant solution composed of aqueous nitric acid and ethanol. The next step is you must examine the specimens under a microscope and observe the structural features. So by adjusting the microscope, we can have a clear picture of the structures of the features. As we complete this step, we know the ice bearing gives the most severe quench. Step 10 is, after noting the microstructural features of the sample, the Rockwell's hardness test should be conducted using the cone indenter for all 6 samples. Then, the hand wheel is turned until the specimen is in contact with the indenter and the pointer of the smaller dial gauge reaches the red dot so that the minor load of 10 kg is applied. Step 12 is the major load is set and the motor is switched on. The hand level is kept in load position for 15 seconds. And the reading is noted down using C scale. Lastly, all the values from the experiment are tabulated as per in data shown. In this table, load P, total load P and scale used remain constant for all 6 quench methods. In the end, we are required to observe and relate the microstructural features and the obtained Rockwell hardness number. We will get a better visualization as we zoom in the sample microstructural features. So this is the annual microstructure feature. This is the normalized, ice quench, oil quench and water quench microstructure features. So the hardness values obtained can be correlated with the microstructure observation. The higher fractions of martensite are observed in better quenchings, thereby resulting in higher hardness value. That's all from me. Thank you.